Well, good afternoon, good evening, good morning to those of you joining us from all around the world. My name is Jeff Erickson. I'm the General Manager for Client Engagement at the Global CCS Institute, and I will be your host on the webinar today. I'm very excited to have the opportunity to provide you with some insights on the present and future of carbon capture and storage in the Middle East region. Next slide, please. I will be joined today by three excellent speakers. Mr. Qais al-Suwaidi, the Director of Climate Change for the UAE Ministry of Climate Change and Environment. Mr. al-Suwaidi will be providing a government perspective on the energy transition and why addressing climate change and deploying CCS is important to the UAE and to the broader region. Ms. Aisha El-Kabali, CCUS lead for Abu Dhabi National Oil Company, or ADNOC, is also with us today. Ms. Kabali will be providing us with an overview of ADNOC's CCUS strategy and its forward plans. And Zayed El-Shehi, the team lead for Reyadah at ADNOC. Mr. Shehi will give us a detailed look into Reyadah, the world's first carbon capture facility on a steel plant. Before we begin, a brief word about the Global CCS Institute. We are an international think tank backed by governments, businesses, and NGOs whose mission is to accelerate deployment of carbon capture and storage. We provide advocacy, intelligence, and connections to CCS, climate, and energy stakeholders. We have nearly 130 members from around the world and staff located around the world as well, with offices in Melbourne, Beijing, Tokyo, Brussels, London, Washington, Houston, and I'm pleased to announce that we have recently opened our office in Abu Dhabi. And I'm proud to say that our new head of the Middle East North Africa region is Mohammed Abu Zara. Some of you may know Mohammed as he has been a fixture in the CCS community in the Middle East and in Europe for many years. Mohammed, welcome to the Institute. A quick note about the mechanics of the webinar today. First, this webinar is being recorded and will be available on our website, globalccsinstitute.com, for those who might have missed the live event. After the presentations are finished, we will have a question and answer session with Ms. El-Kabali and Mr. Shehi. You may submit your questions at any time during the webinar through the Q&A button at the bottom of your screen, and we will get to them as time permits. Please use the Q&A rather than the chat button to submit your questions. To set some context for the other speakers, I'm going to spend just a few minutes providing some information on the global status of CCS. The slides and information that follow are drawn from our flagship report, which was published in October of 2020. The report's a great ready reference for the state of the industry and provides the latest updates on CCS projects, policy, and technology, and it's available for free on our website, globalccsinstitute.com. So some of the findings from that report. First, we're seeing continued growth in carbon capture projects in the development pipeline. We've seen now 4 straight years in which the number of facilities in operation, construction, or development is growing rapidly. Today, 27 commercial CCS facilities are operating, collectively capturing and permanently storing about 40 million tons of CO2 per year. In addition, there are 4 facilities in construction and 102 facilities in development. And that 102 includes 71 new facilities that we added to our projects database in 2021, representing a capacity increase of nearly 1/3 in the last year. Next slide, please. The United States continues to lead the world in the number of facilities in development and operation, driven by a long history of supportive policy and operating experience. The ethanol industry has come on strong in the past year, as has the liquefied natural gas business. There are preliminary plans underway for huge networks, including the Summit Agriculture Network of about 30 ethanol plants, and the Houston Ship Channel project, which is envisioned to ultimately capture up to 100 million tons of CO2 per year. Europe is coming on quickly with many recent project announcements, nearly all of which consist of networks of facilities. And we're really pleased to see this last year a final investment decision on the Langskip project in Norway, and construction underway at the cement plant that will be the initial source of CO2, as well as progress at the Northern Lights facility where the CO2 will be stored. CCS networks are advancing in the UK and the Netherlands most prominently, but we're seeing early stage plans in several other countries in Europe as well. But as you can see from the map, CCS is not limited to North America and Europe, and there are signs of growing activity and investment in many regions around the world, including notably Australia, China, Southeast Asia, and of course the Middle East. Another way to understand the evolution of CCS is to look at the industries involved. The horizontal axis on this table is the timeline beginning in the 1970s, and across the vertical axis are listed various industries. The size of the bubble represents annual volume of CO2 captured and stored, with the smallest bubble representing about 200,000 tons of CO2 per year, and the largest about 8 million tons per year. You can see that in the early days of CCS to the left, it was applied mainly to natural gas and synthetic fuels. But in more recent years, the applications have diversified with facilities in ethanol production, hydrogen production, power generation, waste to energy, iron and steel, cement, and direct air capture added to the mix. So let's now shift to the Middle East, North Africa region. There are currently 3 commercial scale CCS facilities in operation, representing nearly 10% of global capture capacity. And that, by the way, is more than double Europe's current capacity in operation, which is about 4%. The MENA region is poised for significant takeoff in CCS activity in the next decade, perhaps resulting in up to 60 million tons per year of CO2 captured and stored. Now that, for context, is about 1.5 times the current total annual volume globally. This activity is being driven by several factors. There are expansion plans at 2 of the 3 operating CCS facilities. Qatar Gas expects to expand the CO2 capture at its Ras Laffan facility from 2.1 million tons per year to about 5 million tons per year. And ADNOC's El Reyadah plant is also expecting expansion, as we'll hear more about shortly. Several countries in the region have explicitly included CCS in their nationally determined contributions under the Paris Agreement. Saudi Aramco has promoted a circular carbon economy, reduce, reuse, recycle, and remove, which includes a central role for CCS. We're seeing diversification of CCS applications in the region as well. And as I mentioned, and as perhaps an indication of the growth and potential of CCS in the region, the Global CCS Institute now has an office in Abu Dhabi. We see a robust future for CCS in the region and expect that CCS will support both government's carbon reduction targets and the industry's transition to a low carbon economy. So with that as context, I'm pleased now to introduce our next speaker. Mr. Qais Suwaidi is the Director of Climate Change at the UAE Ministry of Climate Change and Environment. Mr. Suwaidi, over to you for your remarks.
Thank you, Jeff. Thank you very much for having me, and thank you to the Global CCS Institute for organizing this event, this very timely event, I think. And also welcome to Abu Dhabi. Hosting a regional office here in Abu Dhabi is of course an honor, and then should also help us here in our region to also excel and speed up our transition towards a more sustainable future. Now, as you know, Jeff and friends, attending the webinar, this session here coincides with the second day of the Abu Dhabi Sustainability Week, a major international event that started back in 2008 from one of the major energy capitals in the world to actually promote sustainable energy, promote sustainable use of resources, and to help us here in the region, but also the world meet, connect, and discuss how we can move forward in the global sustainability agenda. ADSW, Abu Dhabi Sustainability Week, is not the only major event hosted by UAE government to promote sustainability. We also have the World Green Economy Summit in Dubai, also a global event, hosting a lineup of global leaders, both from government and private sector, also civil society, to promote sustainability. Not to mention the Zayed Sustainability Award, IRENA, the International Renewable Energy Agency, and then Expo as well. That's also happening, where sustainability is at the core, and is also the legacy of Expo here in Dubai and the region. So sustainability sits at the heart of our government, our policy making here in the UAE, and also at the heart of our future-looking investment and planning. Back in 2008, as mentioned earlier. So for us here in the UAE, and I can of course provide you with a list of other efforts when it comes to renewable energy, nuclear energy. Also back in 2008, this whole discussion, also Masdar, started back then. And this I think indicates one thing for the UAE government, as the UAE sees itself as a regional but also global leader when it comes to sustainability. For us, it's not about oil versus sustainability. It's not about oil versus climate change. It's not about this trade-off. Nothing is holding us back from investing in the future, basically. So this sort of discussion that's normally floated, that UAE being a major oil producer, investing in sustainability, some sort of paradox that people might identify, that sort of discussion is not in even closed rooms here in the UAE. What really matters for us is to look at what the future holds to us. It's to look at diversifying our economy, and then it's also about responsibility, about our responsibility towards the environment. Environmentalism is part of the UAE's history. It's also part of our leaders' plans since the beginning of the UAE's federation. So responsibility is at the core of this endeavor towards sustainability. It's also about the economic opportunities. So if we speak about renewable energy, Masdar, and then all the international investments, even in renewable energy in more than 40 countries, it's all about that economic opportunity that comes with it, that comes with investing in, again, the technologies of the future. And it's also about competitiveness. So the UAE is, or in fact, the first major investor in renewables here in the region, the first country to have a nuclear power plant, an operational power plant, of course, since now 2 years, which is also clean energy. So this investment in the future is about our competitiveness, to be the first to compete with others. And also it's about, when it comes to renewable energy, it's about investing since 2008 in renewables. Now, even more investments are in the pipeline, but we can speak of 5 gigawatts in the pipeline already in implementation in Dubai, even more than that in Abu Dhabi, and not to mention hydrogen-related projects, not to mention electrification of industry, and not to mention also, or actually to mention CCS, which is really what we're talking about here today. So the first, talking about competitiveness, UAE was the first in the region to ratify the Paris Agreement. The UAE, just after the Paris Agreement, adopted in November 2015, early 2016, UAE creates a Ministry of Climate Change and Environment, with the sole mandate of actually implementing the Paris Agreement. The climate change plan followed in 2017. Climate change plan had a very clear objective of mitigating climate change, reducing our carbon footprint in the country, adapting to climate change, the impacts of climate change here in the UAE, but also thirdly, to seize the opportunities, to diversify our economy through climate action and invest in green technologies. Second NDC followed, and as Jeff mentioned, CCS is part of our second NDC. It's part of what we've been doing in the first NDC, CCS 800,000 tons as part of Reyadah, and then an additional 5 million or 4.2 million by 2030. Hopefully, is also part of our NDC target of reducing our carbon footprint or our emissions by around a quarter by 2030. The UAE also was the first country in the region to announce a net zero target. So hopefully, we'll be achieving a net zero target by 2050 or even earlier. And we also be the host of COP28, which is the COP of global stock taking of what the world has been doing so far, a major COP that the UAE will strive to make successful and in line with the global ambition of mitigating climate change and achieving net zero by 2050. Now, coming to CCS very briefly, so why CCS? Why we need to invest in CCS? Why the UAE is investing in CCS? Although you hear, so looking at the circular carbon economy sort of approach to things, you see the focus on reduction more. Of course, we focus on reduction of emissions more than anything else, but we need all sorts of measures to reduce our carbon footprint. Oil and gas remain a major source of energy today and will remain for the foreseeable future, that we know. And this is why investing in CCS is a matter of responsibility. As expensive as it might be, it is a matter of being responsible towards the environment, towards the climate. So it's a matter of responsibility, that's first of all. And secondly, we're also talking about an energy transition. So that energy transition, it's a transition. It will be a slow transition, huge amount of investments, new technologies will have to come and help us achieve that transition. But while transitioning, we'll definitely need oil and gas. And of course, we need to be responsible in our oil and gas use and of course, use CCS and other possible methods to reduce the carbon footprint of consuming fossil fuel. And also the transition, of course, we don't end our consumption of oil and gas abruptly, because it's not about just transitioning, it's also about maintaining the level of economic development, prosperity as well. So it won't happen, and that won't be accepted, that you transition at the expense of your own economic well-being. So that's also important. Energy security. So the UAE's investment in nuclear renewable energy is of course about being responsible. It's about being sustainable. It's about the opportunities of the future, but also it's about energy security. It's about energy diversification. And this is why oil and gas will remain part of the energy mix in the next few decades for the whole world, because we need to diversify our energy sources. We need to be energy secure. So again, it's about all these reasons, and it's also about in our approach and in our endeavor to achieve net zero by 2050, which won't be an easy target. We need all solutions. We need all of the above solutions. We can't exclude one solution and prefer the other, because again, we need to invest in all technologies and make sure that whatever technology succeeds and proves itself is used so long as it is climate friendly and environmentally sustainable. So that's my input for today. I hope you found that useful. I'll remain available in case there are any questions. If not, please, Jeff, over to you.
Guys, thank you so much for those remarks. So much of that resonated with me, and I found particularly interesting the combination of the responsibility that the UAE has, as well as the economic opportunity and business opportunity and the competitiveness that CCS and decarbonization provides to the country. And there's I think a bit of a battle between the best way to decarbonize the industry. Certainly your remarks are consistent with what we at the Institute believe, which is that it will be a transition. Fossil fuels will be in use for a good period of time. And the right approach is to actually decarbonize the fossil fuels as the best way forward. So thank you so much for those remarks, Qais, very much appreciated. There are a couple of questions that did come in during and after my presentation that I'd like to just address before we move over to Aisha and Zayed. First of all, the slides that I worked through will be available to you on our website along with the recording of the presentation itself, and they should be available beginning early next week. There's a question about the split between enhanced oil recovery, or CCS, associated with enhanced oil recovery and dedicated geologic storage. What is the current split? Most of the projects around the world are associated with enhanced oil recovery. The main reason for that is because that was essentially the root of the economic case for carbon capture and storage. But what we are seeing is an increasing number of facilities, CCS facilities, that are planned for the future. All around the world, including in the US, include a geologic storage component rather than an EOR piece. There's a lot of geographic differentiation, and different countries, different regions will address that separately. But where we're seeing an increasing number of projects that are not associated with EOR, we expect a pretty healthy mix of the two over the midterm. And finally, there was a question about CCU, carbon capture and utilization. And I'll just have to say that my remarks, I always talked about CCS. That's a bit of shorthand from my perspective. It certainly includes utilization for things such as CO2 as components of chemicals. I will say that the volume, the mass that we need, the scale that we need in the midterm is going to be available in geologic storage. There's certainly a contribution that utilization of products will provide, but the scale that's required is going to happen primarily through geologic storage. Utilization often provides the business case to allow for actually both to go forward. So keep the questions coming. Again, as we get into the presentations from ADNOC, I'm sure there will be more, and we'll have the opportunity then to address them all after we hear from Aisha and Zayed. And now I'd like to hand it over to Aisha El-Kabali and Zayed El-Shehi. Aisha, as I said, is the CCUS lead for ADNOC, and Zayed is the team lead for the El Reyadah CCS facility at the Emirates Steel plant. Aisha, over to you. Thank you very much.
Thank you, Jeff, and thanks to the Global CCS Institute for your invitation to speak in this webinar. It's my pleasure to present today on behalf of ADNOC, the CCUS efforts and strategy. And today in my presentation, I would like to share with you more about ADNOC CCUS journey as one of ADNOC's strategic focuses area. Next, please. So first of all, let me start with ADNOC and who we are. So we are one of the world's largest energy producer, founded in 1971, 100% owned by Abu Dhabi government. We have a network of fully integrated businesses for exploration, production, storage, refining, and trading, as well as the development of a wide range of petrochemical products. We are leading low-cost and low-carbon producer globally, and we will continue to look for more innovative ways to maximize the value of our resources while applying the latest technology, and will continue to create energy for life while preserving the environment for the future generation. Next, please. So our strategic pillars are in ADNOC are people, profitability, and sustainability. So let's talk more about the sustainability, where ADNOC, in ADNOC we have committed to protect the environment since our operation started back in 1971. So the sustainability is a key priority for ADNOC, reflecting the vision of the founding father of the United Arab Emirates, His Highness Sheikh Zayed bin Sultan Al Nahyan, who talked about the need for us to protect and preserve the environment for future generations. And as per our 2030 sustainability strategy, we are reinforcing our long-standing commitment to the environmental stewardship across different pillars and initiatives, such as climate emissions and energy, local environment, economical and social contribution, workforce diversity and development, health, safety and security, and business sustainability as well. And today we'll focus more about the emissions. And in order to mitigate the risk of the climate change, we have committed to reduce our greenhouse gas emission intensity by 25%. And this will strengthen our position as one of the least carbon-intensive oil and gas producers in the world. And in ADNOC, we do have different initiatives in order to achieve this target. And we are leveraging also the technology which will help us to minimize the environmental impact. And we believe that CCUS is one of the key innovative solutions which will help us to mitigate the climate change while meeting the global energy demand. Next, please. So the key pillars for ADNOC CCS strategy focus on different parameters and different factors, starting with the environment, which will impact positively in the environment, where the CCUS will help us to reduce the carbon footprint while ADNOC still meeting the global energy demand. Also, it will support ADNOC oil production growth through the CO2 as an enhanced oil recovery, and will unlock potential resources from our portfolio. Another driver here is currently we are injecting gas in some of our fields within ADNOC portfolio, and CO2 is a good candidate for the replacement, which will help us to contribute to avail additional gas to the network. And this is in line with our gas self-sufficiency strategy here in ADNOC. So how we can achieve this? We are in ADNOC working closely with different partners, and we are investing in different technology to further develop this concept. We do have an extensive R&D program to utilize the latest technology, which will help us at the end to have an economical and efficient CCUS project. Next, please. And here we are really proud to have Reyadah as one of the top global facility located here in Abu Dhabi, where this project is fully commercial CO2 capture from the iron and steel industry worldwide. And we started this project back in 2016, and we inject the CO2 in our fields, which is the largest CO2 project in the region. And successfully, it was operated without any HSE issues. Next, please. Now, let me take you through the journey of ADNOC CCUS projects, where we started back in 2009. And ADNOC invested in the CO2 application with the first regional pilot to test the concept of CO2 injection. And basically, expansion project implemented in order to increase our understanding and our knowledge about this process and this technology. So the first pilot in the region was really a major milestone within ADNOC CCUS journey, which helped us to open the door for more opportunities and application within ADNOC portfolio. And in 2016, the injection and the sequestration of the CO2 started in two of our ADNOC onshore fields. And this is the largest CO2 project in the region, where we are injecting the CO2 from Reyadah, which will be presented in details in terms of the operation of the facility by my colleague Zayed. And here it's worth to mention that the extensive data acquisition was implemented before the injection, during the injection, and even it's planned after the injection, along with the modeling efforts to ensure that this CO2, which is injected, has been safely injected under the ground. And the data acquisition currently also will be utilized for our future projects to optimize it more. Next, please. So in the upcoming years, ADNOC momentum and the investment will continue as our plan to have different CO2 technology breakthrough and partnership strategy. Our priority now is to focus on development of the latest CO2 techniques, which will help us at the end to have an economical, viable project and will enable us to optimize the whole cost of the CO2 value chain. And we do have a CO2 deployment strategy, and we develop a CO2 master plan and roadmap, which will help us to establish CO2 value chain, supporting the low carbon ammonia and hydrogen. And this supports our strategy at the end. And we believe in ADNOC that this will be like a game changer in the energy transition. Also, we are developing on top of the classical application, different CO2 innovative cost-effective technologies with an EUR application. So this will be the first industry hybrid concept, which will maximize the CO2 added value with the chemical application. And it's expected to deliver higher value for ADNOC business. Also, we are looking to identify a new CO2 sources at a lower cost of the supply. And we are doing the screening for different potential sources. And we plan to expand our CCS facility operation by capturing this CO2 from different sources. And now I would like to share with you a video presenting our efforts in this domain. So next, please, which is focusing more about Reyadah, which is our successful story. So please enjoy.
الريادة هي أول منشأة تجارية في العالم لمعالجة ثاني أكسيد الكربون من محطات الحديد والصلب. وتعتبر أيضاً the first CCUS facility in the Middle East. الريادة هي أكبر داعم لاستراتيجية أدنوك للاستدامة. نتكلم عن 800,000 طن من ثاني أكسيد الكربون سنوياً، وهو ما يعادل إزالة انبعاثات ثاني أكسيد الكربون من 170,000 سيارة. The CO2 quality is met.
Very good. جزء من استراتيجية أدنوك أن نضمن يكون برميل أدنوك للنفط الأقل عالمياً من ناحية الانبعاثات الكربونية والأقل من ناحية التكاليف. من ضمن أهداف أدنوك للاستدامة 2030 هو التزام الشركة بخفض مستويات الانبعاثات من عملياتها بنسبة 25%.
المسؤولية اللي علينا حالياً هي مهمة جداً في بناء مستقبل يستخدمون ال CO2 بطريقة أفضل من ما كانت عليه.
CCUS أو Carbon Capture Utilization and Storage هي تقنية لها فوائد عديدة. من ضمن هذه الفوائد تساهم في تقليل الانبعاثات الكربونية مما يؤثر بشكل إيجابي على البيئة.
خط الإنتاج في الريادة هو الأعلى من ناحية الضغط في العالم بما يقدر ب 230 بار. طول الخط 43 كيلومتر، والبروسيس بيكون على البايب لاين اللي هو رايح له باب ورميثة،
وثم يتم حقنه في الآبار في حقول أدنوك البرية. استخدام غاز ثاني أكسيد الكربون راح يعزز من إنتاج النفط. Our aspiration is to achieve a 70% recovery factor through the enhanced oil recovery methods. Very good, thank you. عندنا خطط توسعية في هذا المجال عن طريق الانتجريشن مع الهيدروجين بزنس. وأنا جداً فخورة أني أكون جزء من فريق هذا العمل اللي يحول هذا التحدي إلى فرصة على أرض الواقع في هذا المجال.
Okay, so just to conclude my part, I would like to highlight that at ADNOC, we are committed to deliver our CCUS strategy to reduce the environmental footprint while meeting the global energy demand. Building on this successful story of a Reyadah facility, we are expanding our CCS ability and capability also by accelerating our investing in CCUS technology through the whole value chain. Also, we are focusing on the different efficient technologies and optimizing the injection techniques, which will help us to improve the efficiency of the whole operation and have at the end economical projects. So by this, I conclude my part. Thank you again for listening and for your attention. And now my colleague Zaid will talk more about the operation of Reyadah and the facility as well. So Zaid, please.
Good afternoon, everyone. This is Zaid Al-Shahi, team leader at Reyadah Operations. It's a privilege and honor for me to join you today on this global platform representing ADNOC's flagship CCUS project that is currently in operations here in Abu Dhabi. The project is very unique, being considered the world's first facility to utilize the waste CO2 from iron and steel industry to be utilized for enhanced oil recovery operations. Next, please. Being a world-class facility, we have some unique features that is worth to mention. It is, as I said, it is the world's first fully commercial CO2 capture from iron and steel industry. It is also the Middle East first commercial scale CO2 capture plant that has started back in 2016. We are also operating the highest CO2 pressure in the world, which is currently at 240 bar. And the capacity of our facility is around 800,000 tons of CO2 per annum, which is the carbon sequestration equivalent of nearly 1 million acres of forest. Next, please. This slide illustrates the entire value chain of Reyadah. So it starts with capturing of the CO2 there at Emirates Steel. So instead of being vented to the atmosphere, the wet CO2 would be brought to Reyadah for compression and dehydration purposes. Now our facility consists of LP compressor and also the HP compressor. So we are receiving the CO2 at almost atmospheric pressure, and then it will be compressed all the way to 240 bar. Now the final product would be metered, and of course we'll do the quality check, and it's going to be exported through a 43 barrel pipeline for the enhanced oil recovery in Rumaitha field first, and then in Bab. Next, please. This basically illustrates the geographical representation of our location as also our operations. As you can see, we are located in Abu Dhabi in between Emirates Steel plants. We have 1 and 2, which is basically the CO2 suppliers. You can see from our export line, which is represented in red. Our line is equipped with the 2 block valve stations. These block valve stations are basically used for maintenance point of view, as also to be used in case of any emergency. Now, from what you see, the first injection field will be basically in Rumaitha, which is exactly 43 kilometers from our location. And we also injecting in Bab, which is currently or maybe 120 kilometers from our location. As you have seen by now, Reyadah holds a very important role to realize our sustainability ambitions. And we believe that staying committed and being progressive will help us to navigate through the successful journey of transformation. With this, I conclude my presentation, and if you have any questions, please feel free to ask.
Great. Thank you, Zayed. Thank you, Aisha. very much for those informative presentations. There are several questions that are coming through as well. And I want to start with one of the comments, and both of you can come on video as well if you're able to. One of the comments that Aisha made in her presentation, there was an indication that natural gas would be liberated to the market. And so I think that's part of the business case for CCS in this case. And we know that for some governments and industries, the cost of CCS is a major consideration. So Aisha, let's start with you. Can you tell us more about the business case for CCUS in Abu Dhabi?
Yeah, so basically, as you highlighted, there are many drivers behind this one to avail the gas, which will be used to our network. It's one of ADNOC gas self-sufficiency strategy. And also for the production, as CO2 is considered as an enhanced oil recovery method, which will help us to achieve also our targets in terms of the production. So I think, and from my point of view, I think we need, the cost is in general, can be a challenge, but we need to invest more on the technology to reduce the climate change, because it's also an important items in our business. And in ADNOC, we are developing basically low-cost CO2 capture technologies. We are focusing on different techniques to develop this, which will help us in our value chain, and it will create more, efficient projects, and it will also optimize the cost. We are also working with different partners, leverage the experience of our shareholders, and also we are benchmarked with other international oil and gas companies in this domain. And from my perspective, I think we need more integration and identify different innovative solutions. Is really a key factor here, which will help us to expedite and accelerate the cost-effective CO2 technology deployment globally. And this will help us at the end to develop economical, viable, and best-in-class low-carbon projects in the future.
So Aisha, sticking with the business case for just a moment, you mentioned in your presentation a hybrid approach that you were taking with chemical production. I assume that's part of the business case as well. I think that applies to the utilization piece. Can you say a bit more about the hybrid approach that you're taking?
Okay, this one, it will be, we designed this concept to be applied in one of our fields. It's really a unique technology where we will have the CO2 mixed with the chemical. We do have some challenges in our fields, and in order to overcome these challenges, we came up with this concept. We started back to find the polymer or the chemical which will be suitable to our condition. Basically, we did a lot of research and projects and different lab studies in order to identify this chemical. And this chemical has been successfully tested in one of our fields. And we want now to test this chemical with the CO2, and this will be implemented as a first time. Basically, based on the different modeling efforts and different lab studies and our experts here, we believe that this is one of the promising technology which will help us to overcome of our challenges, our subsurface challenges, and it will help us also to reduce the carbon emission because it will inject the CO2 under the ground. So we're working to utilize it, to utilize the CO2 in an efficient way, and at the same time, it will help us to inject more CO2 volumes in our fields in an efficient manner.
Right, thank you. So that's very helpful. It's actually the hybrid approach you're talking about is during injection rather than as a separate process. And I think another example of the technology development that ADNOC is pursuing to reduce the cost. So thanks, very helpful for that. Let me move over to Zayed. Zayed, can you talk a bit about the operational challenges that you faced in setting up El Reyadah? What lessons learned can you share for other companies and countries that may want to set up a similar facility?
Yeah, basically we had lots of initial challenges, I would say, with regards to the CO2 end. But you know, we have a lot of new system in place, so all this new system has to talk to each other. But with time, we have overcome these technical issues, I would say, and now we can reliably process the compressed CO2 and safely store it into the ground. This is it's a new technology, and it is a proven technology also. Personally, I believe it's the technology of the future, and I hope that our model will influence other countries and industries also to follow the same model to achieve their own CO2 reduction and climate change set targets.
Can you talk a bit about the particular capture technology? One of the questions that's coming through from the audience, the particular capture technology that's deployed at El Reyadah.
Well, the whole facility is a new technology, but we have a lot of good example in terms of technology. But I will give the example of the leak detection system that we have. It is an effective technology. The purpose of that technology is to identify any kind of CO2 leaks that happens or in the pipeline, and it will help us to identify that. It is found to be very useful and effective in a way that we are extending this technology across ADNOC onshore fields.
Right, very good. So over to Aisha. I think this is for Aisha. One of the slides that Zayed showed a pipeline that runs essentially across the coast down to the oil field. Is there an opportunity to incorporate additional facilities, perhaps from other industries, to also contribute CO2 into that pipeline using the network approach that is being deployed in places like Europe and the United States? Or is the pipeline intended to be dedicated just to ADNOC's facilities and the El Reyadah plant in particular?
Okay, so the current pipeline is basically going from Reyadah to Rumaitha and then Bab. And actually, we are working in the future where we are identifying different CO2 sources, potential CO2 sources, in order to achieve our targets. So basically, we are developing a CO2 master plan where we are integrating the subsurface and the different storage location for the EUR purposes. And we are working to integrate the subsurface project with the surface in a way that we are integrating the network, the facility, and the pipeline, which will help us at the end to make an economical case. That's why this CO2 master plan is very important, and it helps us to have an integration in terms of the timing, in terms of the volume required to inject the CO2. And also, we are here integrating the technology on top of the subsurface and surface to make it as a whole value chain. So I think the integration between the subsurface and the surface is very important to optimize the facility network, which will help us to identify the different location and the optimum time to start the injection at this site location. So the current facility is belong from Reyadah to ADNOC onshore fields. And in the future, we are looking, and it depends on the different potential CO2 sources, the location of these sources, with the demand as well. So it is integrated between the source and the demand. So from the surface to the subsurface.
Great. And can you say more about building partnerships and collaboration to drive innovation in the CCUS space?
Actually, yesterday and today I was in the Abu Dhabi Sustainability Week. I like to participate in all these events because I think it's a good platform to exchange the knowledge and the information, and also to collaborate with these different partners. Because I believe that the collaboration is one of the key factors to have a successful CCS projects. And in ADNOC, we are working with different leading companies, academic partners as well, individual, governments, different stakeholders, throughout the whole CCUS value chain, starting from the capturing to transporting the CO2 until the injection site. And this all will help us to further develop the different concepts and to accelerate as well. So just to focus in the last 2 years in ADNOC, we do have different agreements. For example, in 2020, ADNOC signed a strategic framework agreement with our partners like ENI and Total Energy. And this help us and enable us to explore more opportunities and joint research also in this technology. And last year also in 2021, the UAE and Japan agreed to also cooperate on the ammonia and the carbon recycling technologies. Actually, this agreement followed the signing of the Memorandum of Cooperation between ADNOC and the Japanese Ministry of Economy, Trade and Industry. And this highlights the joint ambitions of our countries to harness this new commercial feasible technology to reduce the carbon footprint and the emissions towards the decarbonization. There are just a few examples on how we are working here, because the partnership is a key. And we do have a connection with different leading international organizations and government, where we are exchanging the knowledge and also the different, technology, which will help us to leverage this CCUS technology. And at the end, this will help us to achieve our targets and also to expedite the process of the deployment of this technology.
Great, thanks for that. There are a lot of questions coming through from the audience, very much appreciated. I know we won't be able to get to all of them, but we'll catch as many as we can. One of the questions that's come through, I think, is for Zayed. And the question is, what's the biggest difference and unique challenges when it comes to capturing CO2 from steel, as opposed to a coal plant or natural gas plant or natural gas processing?
Can you repeat the question?
What are some of the unique challenges that come from capturing CO2 from a steel plant, as opposed to other types of facilities?
Yeah, first let me explain about how we have designed our facility. Our facility has been designed to cater the purity of the CO2 that we are receiving from iron steel industry. To be in particular, one of the challenges that we face in the plant, it has nothing to do with the CO2 supply from steel industry. Is the HP compressor that has been customized to do this operation. Of course, you see you have a new compressor fully customized for this plant. So in the beginning, we faced some technical issues, which we have, as I said, we have overcome.
Right. Can you talk about the level, Zayed, of purity that the CO2 gas stream is required in order to inject into the reservoir?
Yeah, the requirement is we should, it is about 99.5 CO2. So it's like our export CO2 is a bone dry, it is nearly 99, more than 99% purity of CO2. The purity that we receive from the steel industries are around 89% CO2, and the rest is moisture. So that's why we are treating that moisture in our plant before the final compression.
Right, and then back over to Aisha for a bit of the business case. Is there an internal carbon price that ADNOC has established to help prioritize capital investment, decarbonization, and project performance, or is it more based on the merits of individual decarbonization proposals?
Currently, most of our project, or in general, all of our project is basically meant for the enhanced oil recovery. So this project, that's why we call it as a CCUS. So it is utilizing and storing at the same time. So we are focusing currently in ADNOC more about how we can ensure that the CO2 is injected under the ground and how it will be beneficial for us in terms of reducing the emission and at the same time it helps us in our contribution to our growing oil demand. So this is our main focus here in ADNOC currently. And today, as we presented, that we have currently 2 ongoing projects across our onshore fields, and they are contributing to unlock new value for every barrel. So we are focusing on this aspect, which will help us to reduce the environment projects. This is from ADNOC point of view. And also we are working on different guidelines internally about what is the optimum in terms of the monitoring plan, how we make sure that the CO2 injected in the ground safely. So that's why we have certain criteria that we considered. So it is basically about the injection and about the benefit from this injection. So currently we are focusing on this EOR project, which support the economic sustainability and the environmental as well. So this is our main focus now.
Right, okay. And Aisha, another question that came through was with respect to the environmental impact of EOR. And because EOR is being utilized to increase production in a particular field of oil, can you speak to the environmental sustainability of EOR?
Yeah, so it's a good point. So what we are doing here in ADNOC, it is a CCUS process. So utilizing and storage. To ensure, first of all, that there is no impact on the environment, we design a proper monitoring plan. We have a plan before the injection startup, and as a baseline to be as a reference for the CO2 movement and how it's moving, and then during the injection as well with the different frequency. And this is not only about like the 1 or 2 monitoring types of data acquisition. No, we do have an extensive design of this program in terms of the logging surveys, in terms of the pressure, in terms of the sampling, in terms of also some seismic to map the CO2 movement in a 3D to ensure that this CO2 will be stayed under the ground. Also, before that, the design that we selected, what is the distance between the producers and injectors? What is the horizontal section? What is the pattern? So all this has been considered in a designing stage. And now, even in the designing stage, it has been also planned to have, in case any CO2 will come to the injector, to have a recovery plan units in the surface. So any CO2 will come to the surface, it will be re-injected again. And basically, we are modeling all this in a high analytical and high simulation modeling capabilities here within ADNOC to mimic what is happening in the field within these models, 3D modeling, analytical approach as well, to ensure at the end the CO2 will stay in the ground. So basically from our projects is most of the CO2 will stay underground. It will be dissolved with the oil, and in case there is any CO2 will come in the producer, there is a plan to separate the CO2 and to re-inject it again in our fields to make sure that this is stayed safely and also permanently in the ground.
So Aisha, that you're talking there about kind of the security and assurance that the CO2 that is injected will remain underground. The
Yes.
question that came through was respect to the life cycle emissions of EOR and the fact that actually more oil is being produced through EOR, and what about the impacts of combustion? Now, I've seen studies that do address the full life cycle impacts, and there's a couple of assumptions that are made in those studies. You know, a question is it actually adding oil to the market and ultimately combustion, or is demand static, and it's a matter of being more efficient from injecting from an existing field than a new field. But can you talk a little bit about the life cycle equation or the environmental benefits of EOR from a full life cycle analysis, or is that beyond what you're able to talk about today?
Yeah, it is one. It is very good point that you raised. Also, the timing of the injection. Is it like a virgin area that we are currently start to inject the CO2 there, or it is like, is it like there is like some water injection before this one? What we call it sometimes it's like a secondary mechanism or it's a tertiary mechanism. So the timing of the injection into the field, also the volume that we are injecting, the mechanism itself. Some of the project is also using a continuous CO2. Other project is using like a WAG, where what I mean by WAG, it's like a water alternating gas. So like for some certain period, we are injecting CO2, then we are converting it to water. So we are studying and assessing all these parameters in our design stage for the future projects to ensure that the scenarios that we will select it will help us in terms of reduction the emissions and to have a proper sweep of the oil. We are targeting to have at the end a project where it will help us in terms of the environment to reduce the emissions, and it will help us also in terms of the economical sustainability. So we are thinking about both aspects, and that's why, in my point of view, I think the design is a very important items here. How you are designing your projects, what is the different parameters that you are considering, and this at the end will help us to select the best scenario, and basically this will help us the ultimate objective to achieve all your targets in this domain.
Great, thank you. A couple of questions back over to Zayed with respect to the capture facility. First of all, a question whether the Ember Steel plant was that a retrofit to CCS, or was the steel plant built new with the capture facility? Let's start there.
We have actually designed our facility for the purity of the vented CO2. So Ember Steel plants were there already, and we built the Reyadah based on that specification.
Right. So to an existing plant rather than to a new plant.
Yes. So there was no modification was required. We worked against that specification, as you can say. Yeah.
Mm-hmm. And so you're capturing about 800,000 tons per year. Do you inject all of it into the oil fields?
Yes, whatever we are receiving from steel industry, we are fully injecting it in both Rumaitha and Bab field.
Right. And you were talking previously about the compressors And that prompted a question: what's the reason for very high pressure in the transport line?
Yeah, this is a requirement for the EUR. So the EUR pressure requirement, we should be in between 220 to 240 bar. This is the guidelines, and this is the requirement which have been set for the enhanced oil recovery operations.
Aisha, perhaps you can talk about the need for high pressure CO2 in the oil field.
Yeah, it depends on the designing phase again. So basically the depth of the formation that we are injecting, and also the other parameters that we need to consider it in terms of the rock quality, the fluid properties. So there are a list of parameters that we need to consider in order to make sure that this pressure will help to have this CO2 at a supercritical stage, or the phase that you prefer to have it, and then you will start to inject the CO2. So we are considering different parameters here: the pressure, the material, the completion as well, the pipeline also size. It's all need to be considered, and it comes basically as a starting point from the subsurface. That's why, again, I think to emphasize on the designing stage, all these parameters need to be considered, need to be assessed properly. And basically what we did, we utilized and we get all the lessons learned from our first project, which was in 2009 as a pilot. And in order to increase our understanding and our knowledge, we extensively review all the data that is available, and basically based on all the experience that we get, we find that this is the best design. However, we are always looking to optimize more in the future projects. That's why all this data acquisition we have here in ADNOC Thamama Center, a center where we are looking with the different experts, different also technology that has been utilized in order to monitor and review all this available data. And then it helps us to be integrated with our models, and then it helps us to improve and optimize the future projects.
Very good. Quite a few questions that have come in about the process, the technology associated with the capture at the steel plant. Again, back over to Zayed. Can you talk about how the steel making process is decarbonized? What are the major sources of CO2 that you are capturing, from the process at the plant?
Yeah, to be honest with you, I haven't been there, so I'm not sure. I'm not really sure about their process. Yeah.
Right. Okay.
Yeah.
I do know typically on a steel plant, there's high temperatures are required for the steel making process, and the CO2 is emitted from the metallurgical coal associated with that. I'm assuming it's the same there at the Emirates Steel Plant. I think we need to finish up here. There are we captured the theme of many of the questions that came through. There's some more deep kind of technical questions that I'm having a challenge understanding what the questions are. I think those might be best addressed offline. So with that, I want to thank the participants, Qais, Aisha, and Zayed, very much for your participation today. Quite informative. We're excited to be working with ADNOC in the region. One of the things I didn't mention previously is that ADNOC was actually our first member based in the Middle East. And we're looking forward to continuing to work with ADNOC and with other stakeholders in the region. Ben, if we can just put up the last slides to finish up. Great. So just wanted to remind you again that the global status of CCS report that I mentioned earlier on is available on our website, globalccsinstitute.com. You can follow us on social media. And if you do have any questions, I've put in the general information email address for the Institute. And I've also included Mohammed Abuzara's email address. His first day was yesterday. So I know that he's the ADSW this week, the Abu Dhabi Sustainability Week. And so you'll need to give him a bit of license to in the time it takes to respond to him. But I know Mohammed's excited to be there and really looking forward to engaging with all of the stakeholders in the region. With that, I'm going to close out now. Thank you all very much for your attention. Last thing I'll say is that both the recording and the slides will also be available, as I said, on our website sometime within the next several days. And looking forward to seeing you all on the next webinar that the Institute is hosting. And hopefully we'll be getting back to live events sometime soon. Looking forward to seeing you all then. Thank you very much for your attention. Enjoy your evening, your afternoon, and your morning. Thank you.